Hello, and we're getting closer to the beginning or the start of the spring term. I'll be teaching two courses. Many of you are enrolled in both. One of them is an introduction to excavations. It's called Excavation 2, which is EX201. This is the first time this course has been taught. Unlike other courses, this one has just been completed actually, and I have just turned it from taking information out of the textbook that I chose, which is about say shoring systems, their design, and let me get back up here so you'll make sure you got the right book. This is monstrous. There's the book. You should have an e-book. Be still. Excavation systems, planning, design, and safety. Well, there you go. There's something to talk about. The excavation systems. What is that? That's shields, trench shields. That's shoring, aluminum, hydraulic vertical shoring, whalers, all kinds, cofferdams. There's a uh, uh, tons of different kind of protective system. But this is going to talk about those systems, uh, how to plan for excavation, the design of the systems, and safety produced by these excavation systems. This book is rather. Uh, Let me put it this way: there is a bunch of information in this textbook. To give you an idea, if you can see my little arrow, there's 529 pages in this textbook. This is an engineering level book. However, we're not going to cover all of the designs and all of the uh, considerations that an engineer would have to deal with, but we're going to skim through some of it. We're going to take a deeper look at some as opposed to others. I'd like to come out of here at the very, very minimum of you understanding what it would take or the five things you need to know uh, to be considered as a competent person. Now, realizing that your employer is the only one that can designate someone as a competent person, but usually that employer would like for that guy to go through. I think there's about five things. We'll get into those: soil classification, dewatering, supervision, protective system inspection, site inspection. About five different specific things that they must do on a daily basis. And I want you to understand and know and understand what those things are. So in case your company is in need of a competent person, you might fill that bill for them. So I'm really struggling with how to present this. I don't think I can make it interesting. It's going to be about excavation subpart P. Uh, I think that's 650. We'll get to it here in a minute, but it's going to be a lot about the rule, the OSHA rule, and it's going to talk about the history of a little bit about history leading up to the implementation of OSHA and specifically the excavation spinoff from the general construction. Excavation has its own little niche as far as safety rules and regulations in OSHA. Official name of the book, written by Joe M. Turner. Never heard of him till I uh, came across this textbook, but he's kind of been involved in protective system design for many years and has been kind of uh, motivator, let's say, on safety in trenching and awareness of the difference between trenching as it relates to things like building highways. All have their hazards, of course. Uh, Going through a little bit of stuff, just trying to find a good starting point. Here is table of contents, but if you, I think you can, yes, you can see these. These are links. We'll start out in week 2, talking about this introduction portion of the book. And I don't think there's anything. You can see that there is a scary little guy right here called forces. I don't know if any of you've even had any taste of physics whatsoever. I have bits and pieces, but that's about all we're going to cover. Is you will need to understand what static forces are, what static physics is about, what distribution of forces are. When you think of a piece of plywood holding back the wall of a trench, those forces are distributed across that piece of plywood by uh, the different forces that push the dirt out from the side, such as surface influences, traffic, all that kind of stuff you will begin to understand. So this chapter 2, engineering structural principles, we'll talk about that. I may have some notes and stuff where I was practicing uh, free body diagrams, they're called. I want you to know what that is when we get into that chapter, and how to go about determining, where the forces are going to be the most or the least. And also the term static means stationary, right? Or equal or not, as opposed to dynamic physics. Dynamic physics would include friction, cars running into each other, uh, you know, all that kind of stuff. But this is static physics. This is a force. If you take both of your hands and put them together like you're clapping and push equally, you would have the basic formula for static physics, that the sum of all forces equal zero. In other words, neither hand is moving in any direction. So the sum of force A and the sum of force B with pushing against it is equal. For every action, there is a reaction. That's one of the early laws of physics. But our for shoring, you don't want anything to move, right? You want the shoring itself, whatever it is, whether it's fin form or any of those things. I'll throw out some terms and get around to explaining them, or the book will. But fin form is just like a piece of firewood, plywood holding back the walls of the trench. So that'll come up here directly. But for now, I got some things I want you to look at in chapter 1, and I've highlighted them. I have a PDF myself, and you have an ebook which you can highlight. But here is the focus of the book. It says the focus of this book is excavation safety and excavation work productivity. This, let me finish here. There was the time when these two concepts were seen as being at odds with each other. However, over the past 60 years, and maybe longer now, a fundamental concept has changed that view. The concept is that excavation safety is just another aspect of what it takes to produce the end product. Now let's stop for a minute here. I'm not going to take up all day long trying to introduce you to this book, but I'm going to say, there you go, right there. The concept is that excavation safety is just another aspect of what it takes to produce the end product. In other words, it's not like all of these things digging and shoveling and trenching and putting pipes in the ground or over here, and safety is way over here. Safety is just another link in the chain of productivity. In other words, without safety, you can't be productive because injuries stop jobs, slow down, cost money, uh, impede progress. So safety is just as important as running the excavator, digging the trench, hauling off the dirt. It's just another part of the chain of productivity. Failure to adequately provide any of the elements amounts to project failure. Now, however, today, by far the most costly damaging failure is seen as failure to produce effective safety. And I'm not going to read this whole chapter. I just wanted to point out some things. We've come to accept that the value of human life is greater than the value of what is constructed inside the excavation, and that in all cases excavation work and must be produced without all cases in all cases work can be and must be produced without injury to workers. So that's our goal: is keep moving forward, but do it safely. I have this that says we can't plan and produce without consideration of soil stability. In an unstable excavation, the production work cannot be performed and workers in that environment are not safe. Shoring stabilizes and protects simultaneously. And this is like a little history lesson, so I'm going to keep on and then I'm going to turn it over to you. In the first half of the 19th century, increased excavation productivity in the form of moving less dirt and avoiding, where I lost my place, planned and excavating cannot be performed and workers in that environment are not safe. So where did I stop? This is what I want to read, right? It's hard to talk about excavation safety without talking about the Occupational Safety and Health Administration. That's OSHA. And shoring. Both of these terms are synonymous with excavation safety. Due to its dual nature, the word shoring is also closely associated with excavation production. You can't go forward unless you're safe. Excavations cannot be planned and produced without some consideration of that. There's where I was, of soil stability. In an unstable excavation, the production work cannot be performed, and workers in that environment are not safe. So shoring stabilizes and protects simultaneously in the first half of the 19th century, increase in excavation productivity in the form of moving less dirt. Let's see if I can make this work now. And avoiding damage to surrounding facilities, not digging faster. That is the realm of excavation equipment technology, drove the development of shoring technology in the latter half of that century, and increased concern for worker safety became a second driving force. They both complement each other. However, faster and more efficient ground stabilization is most likely still the major mover of shoring technology development. Aside from stable ground issues, there are other aspects of worker safety associated with excavation work, the major one being existing subsurface facilities, what's in the ground already. In this area, protection of the lives of workers and surrounding public is foremost, with cost of damage to facilities being secondary. OSHA, as it relates to workers, and the Common Ground Alliance, as it relates to everyone involved, over the last half of the century have elevated this important issue. Now, Google Common Ground Alliance, that's part of an assignment. It is an organization composed of everyone that does things under or in the dirt. It has best practices for those of you who went through erosion, sediment, and control at work sites know what best practices means. It means this is what you do in this case. See if you can find, first of all, the organization Common Ground Alliance, and furthermore, see if you can find the document that talks about their best practices, and even further, see if you can locate. I think it's like section 2-12 or 12-2 that talks about locating the different ways to the way to improve on locating underground utilities. You're going to come across some categories: surface work. The book itself focuses on excavation and safety, and below surface work. That's what we're going to talk about mostly. Here is the rule: OSHA subpart P. It was written below surface, below surface work is the category of excavation work that OSHA subpart P was written for. 1926, which is construction, dot 650, which is subsurface work, below surface work. OSHA states the scope and application. This subpart applies to all open excavations made in the earth surface. Now, it goes on, and I'm going to give up here just a minute. This below surface work is the category. Let's see, did I read that of OSHA? And that's what it's written for. 19650A states the scope and application. The subpart, which is subpart P, applies to all open excavations made in the earth's surface. Excavations are defined to include trenches. And now 1926-51 talks about the safety, and it goes into how many excavations happen here and happen there, and I'm not going to go through this, but 1926-52 and all the remaining appendices that's added to the rule apply to worker protection from cave-in. The entire 29 CFR Part 1926 safety and health regulations for construction apply to all constructions operations. However, OSHA subpart P is specific to when excavation work causes there to be a hole in the ground, subsurface. Okay, now that takes us through some categories, or to some categories, which is, I'm not going to talk about all of these. They're pretty self-explanatory. It's part of your reading assignment. And your reading assignment, I think, goes on to include terminology. So be sure you know not your definition, but not necessary, but what OSHA defines as excavation. Now, here we go. We're getting into, can I copy and paste? Is that okay? No, it's not. Uh, I need everything mostly in your words. And listen, the reason I'm doing that is because, as I said in another video, going through through college, when I got home and I studied, I tried to put everything that I needed to know in that book in my words. And that caused me to remember and understand. And remember, speaking of remember, going back to what I said in another video, in the other course, I think, about vocabulary. If you don't know the meaning of the word in this book, stop and look it up. It will amaze you how it helps your understanding of what the book is trying to say. Talks about how they define a trench. It talks about egress, ingress, 25 foot. The ladder is a way. It talks about some things we all know, uh, but the first assignment's going to have some questions over This knows excavation industry. There's a definition. There's a definition of that. Production work. What is that? The production work. The separate. Okay, there are two aspects to work in an excavation: constructing the excavation, digging the hole, and constructing the work that caused the excavation to be open. Why did you dig the hole in the ground in the first place? Or that is to be buried inside a pipe, right? Buried inside the excavation. This is the production work. Then it gives you an example about piles being driven into the ground. And I'm going through this because I'm trying to emphasize to you to understand what this is saying. Uh, as I said before, here's the industry makeup, a little bit more like these are the people involved. I don't know if I got a question about that. I don't think so. That may come later on in another deal. Now, each one of these sections, now, as you can see over here, we're in section 1, and it goes all the way down to here, section, which will put us in section 2, and that will be a whole nother world for us to jump into. But all of this stuff here that's in section 1 is leading up to section 2. Now, here, I don't think I've gotten this far. We're getting to talk about our regulations, and trust me, I don't think I'm going to be able to make this very interesting. It's just important that you know as much as and retain as much as you can from this course, because you're going to be of value. You're going to be a value added employee. You're going to know some things, understand some things that others may or may not know. So I'm going to leave us right there because we're kind of at a when I go back to the let's just go back and see. I'm going to put this video right in here, and this is in week 2, the intro video. So we're going to stick it right in here in a bit once I turned it into a video. And having said that, what I'm going to do now is I'm going to uh, stop this video. I'm going to put it in that module 2 under the video thing where it says weekly overlook or something like that, but it'll say video. You can go back through this and see what I've emphasized, and then there'll be an assignment at the end of week 2, which is based on some of the things we just talked about here. No worries, you will do fine. Same thing as usual, you know, it's also said in that other video. This has been on my mind. We're in an associate degree program. Uh, if you can't cut this mustard, you're not going to be able to cut the mustard of a leader in a construction company. So, uh, and it doesn't mean doesn't mean you actually don't have the capability. Uh, can't, in my words, is like you won't. You're going to have to put forth an effort. There's going to be a lot of information coming at you. Do the best you can to retain it, and I'll do the best I can at presenting it. And I'm not going to put you in a situation where you got to understand algebra, trigonometry, and things like that. We will look at some of that stuff, but we're not going to dwell on it. Okay, I think today is like the 3rd, maybe, and we'll be starting on Monday, the 8th of April. And if you have not uh, got your textbook or any other things that's going to hinder your progress, let me know.